Hi guys, Meng Adlaw. For this video, I will be presenting to you about solving rational inequalities. This is a continuation of my previous video about solving rational equation. But before we proceed, do not forget to click that subscribe button below. So to start, we have solving rational inequalities. For the lesson objective, at the end of this video, you should be able to solve rational inequalities. This topic requires us a prior knowledge on the following: performing operations with fractions, finding the least common denominator, the concept of a number line, and writing an interval notation. So how do we solve a rational inequality? To solve a rational inequality, we need to follow a step-by-step procedure. So number one, write the inequality with a single fraction on the left side of the inequality and 0 at the right side of the inequality. Then number 2, we need to find the value that will make the numerator and denominator equal to 0. Number 3, we need to indicate these values in the number line. Then step 4, we need to check for the solution set. And finally, we need to write our answers in interval notation or in a set builder notation. So let's proceed directly to our examples. For example 1, we are given this inequality: x plus 7 over x is greater than or equal to 0. So for the first step, we need to set the right side of the inequality to 0. So since we have 2 here, we need to use the subtraction property. So we need to subtract 2 here, and we will also subtract 2 at the left side of the inequality. So the resulting inequality becomes x plus 7 over x minus 2 greater than or equal to 0. This time, our left side of the inequality is now 0 because 2 minus 2 is 0. And since we have the negative 2 here, and we have one fraction x plus 7 over x, we need to combine these two fractions because we can consider this whole number 2 as fraction because it has an assumed denominator 1. So we need to combine this first fraction and the second fraction by, of course, by finding the LCD. And the LCD between these two fractions, we have x and assume 1 here. So our LCD should be x. So to combine this fraction, we need to divide x divided by x, then multiply to x plus 7. So we have here x plus 7, then we copy the minus. Then x divided by the assumed denominator 1, then multiply to 2, that gives us 2x. So we just simply copy greater than or equal to 0. Afterwards, we need to combine like terms in the numerator. So that is 7, which is constant, and x minus negative x minus 2x is equal to 7 minus x. So we have here the denominator x is greater than 0. This time, we need to find the value that will make the numerator 0. And of course, we need to find the value that will make the denominator 0. The value that will make the numerator 0 here is, of course, 7, because 7 minus 7 is 0. And the denominator, the value that will make the denominator 0 is, of course, 0. So if we have to indicate this one in the number line, the denominator x, which is equal to 0, so we have here the number line, and we have here the boundary. So we have to indicate this one in the number line, which is 0. And of course, the 7 should be indicated in the number line, which is here, which is 7. So this line divides the number line into 3 regions. We have here the first region, the second region, and the third region. So if x is 0, that will make the whole function, that will make the whole fraction undefined. So that's why we have here a hollow dot. A hollow dot indicates that this value 0 is not part of the solution set. So to check if 7 is part of the solution set, we need to go back to the original inequality. So if x is equal to 7, which is the value that we indicated here, if x is equal to 7, we need to substitute this one to the original inequality, which is x plus 7 over x. So that is 7 plus 7 over 7 is greater than or equal to 2. So 7 plus 7 is 14 over 7 is greater than or equal to 2. So that is 2 is greater than or equal to 2. So this is a true statement. Why? Because 2 is equal to 2. So since this is a true statement, so meaning 7 is part of the solution set. So to indicate this one in the number line, we have to have a solid dot. So different from the 0 here, this is a hollow dot because 0 is not part of the solution set. Why? Because 0 will make the whole fraction here undefined. That's why it is not part of the solution set. While 7 is part of the solution set, that's why this is a solid dot. Now to proceed, we have to check one value from each of the regions in the number line. So from this region, we need to check one value from this region whether this region will give us a true or false statement. For example, For example, we choose negative x from this region. So if x is equal to negative 3, we will substitute go back to the inequality. So that is negative 3 plus 7 over negative 3, which is greater than or equal to 2. So negative 3 plus 7 is positive 4 over negative 3 is greater than or equal to 2. Now, since this is negative and 2 is positive and any negative number is less than positive, so this is a false statement. Now, so meaning, if negative 3 will give us a false statement from this region, all other values that can be found from this region will also give us a false statement. This indicates that this region, all the values that can be found from this region are not part of the solution set. So if these are not part of the solution set, so we will not shade this region. So let's proceed in the second region. We need to choose one value from this region to check in the inequality. So for example, we will choose x equals 1. So we will have 1 plus 7 over 1, which is the x, is greater than or equal to 2. 1 plus 7 is 8 is greater than or equal to 2. 8 over 1 is of course 8. So 8 is greater than 2. So meaning this is a true statement. If 1 will give us a true statement, this goes to follow that all the values that can be found from this region will also give us a true statement. If this will give us a true statement, so we need to shade the values in this region. Next is from this region. For example, we choose x equals 9. Remember that our number line does not only end at 8. It still continues to 9, 10, 11 until positive infinity. For this example, we will choose 9. So that is 9 plus 7 over 9 is greater than or equal to 2. So that is 16 over 9 greater than or equal to 2, which is 1 and 7 over 9 is greater than or equal to 2. 1 and 7 over 9 is less than 2, so this is a false statement. So since this will give 9 will give us a false statement, that means all the values that are found on this region will give us a false statement. So from 8 or 7.5 up to positive infinity will give us a false statement. So meaning our solution set for this inequality is illustrated in this illustration. So to write the interval notation for this solution set, we can have 0 up to 7. So what does this mean? The boundary here, which is 0, is not part of the solution set. 0 is not part of the solution set, that's why we use the parentheses. That is being indicated in a hollow dot. While 7, we use the bracket here because this boundary 7 will give us a true statement, so meaning 7 is part of the solution set. Meaning, the solution set of this inequality is in between 0 and 7, that includes positive 7 here. So these values are the solution set for this inequality. Second example. So let's proceed to example 2. For example, we are given this inequality, x plus 4 over x minus 8 is less than 0. For this example, our right side of the inequality is already 0, so no problem with the right side. With the left side of the inequality, we also have one fraction, so there is no problem with the left side also. So to proceed with the solution, we will find the value that will make the numerator 0 and also will make the denominator 0. For this example, the value that will make the numerator 0 is equal to negative 4. And the value that will make the denominator 0 is positive 8. And we need to indicate this one in the number line. So for example, this is our number line. We need to indicate the boundary, which is negative 4. This is the value that will make the numerator 0. And we will also indicate the value that will make the denominator 0 or will make the denominator undefined, which is positive 7. We indicate here a hollow dot for 8 because 8 is not part of the solution set. Why? Because 8 will make the whole fraction undefined. Now, we will need to check if negative 4 will give us a true statement. So we will substitute negative 4 to the inequality. So we have negative 4 plus 4 over negative 4 minus 8 is less than 0. So this is 0 over negative 12 is less than 0, and that is a false statement because 0 over negative 12 is 0, which is equal to 0. So meaning negative 4 is not part of the solution set, so we will indicate this one as a hollow dot. As you can see, the number line is being again divided into regions. This is the first region, this is the second region, and this is the third region. So to check a value from this region, we choose negative 5. So substitute negative 5 to the inequality. So we have negative 5 plus 4 over negative 5 minus 8 is less than 0. So we have negative 1 over negative 13 is less than 0. Since both the numerator and denominator are all negative, so we can write this one as positive 1 over 13 less than 0, which is a false statement because every whole number are greater than 0. So meaning, negative 5 will give us a false statement. That means all the values that can be found in this region will give us a false statement. That means these values are not part of the solution set. To proceed with the second region, for example, we choose positive 1. Substitute in the inequality. So we have 1 plus 4 over 1 minus 8 is less than 0. So we have 5 over negative 7 is less than 0. So any negative number is always less than 0. So this is a true statement. So if 1 will give us a true statement, all the rest of the value that are found in this region will give us a true statement. So any value that you are going to choose from this region will give us a true statement. So since this is a true statement, so we will shade this region here. Now for the third region, we need to choose again another value. For example, we will use x equals 9. Substitute in the inequality, so that is 9 plus 4 over 9 minus 8 less than 0. So that is 13 over 9 minus 8 is 1 less than 0. So 13 is less than 0 is a false statement. So that means all the values that can be found in this region will give us a false statement. That means we will not shade this region. So the solution set for this inequality is being illustrated in this drawing here. So we have the boundary, which is -4, which is not part of the solution set, and the boundary, which is +8, is also not part of the solution set. So our solution set for this inequality is in between -4 and +8. So the parenthesis indicates that -4 and +8 are not part of the solution set, only the values in between them, including the decimal value. Let's proceed to the third example. We have here the number line. For example, you are given this inequality. X minus 9 over x is greater than or equal to 0. So we have no problem with the right side of the equation because we already have 0. But in the left side of the equation, we have two fractions. So we need to combine these two fractions into one by finding the LCD. So our LCD for this fraction will be x. X divided by the assumed denominator 1 here, which is x multiplied to x, that gives us x squared. Then we copy minus. X divided by x is 1 and multiplied to 9, which is 9. Then we copy greater than or equal to 0. Since x squared minus 9 is factorable, so we need to factor out x squared minus 9. So the factors are, we have x minus 3 times x plus 3. That is over, we copy the denominator x. This time, we need to find the values that will make the numerator 0. Since we have two factors here, so that means we have two values of x that will make the numerator 0. In this case, if we are going to substitute +3 here, so +3 minus 3 is 0. Then 3 plus 3 is 6. So 0 times 6 is 0. So that will make the whole fraction 0. While on the other hand, we also have here -3 plus 3 is 0. Then 0 times -3 minus 3 is -6, so that makes it 0. So we have two values that will make the numerator 0, the +3 and the -3. And while the denominator, we only have the x. So x must be equal to 0. So we have three values here indicate in the number line. We have the first value, the first boundary, which is the 3, and the second boundary, which is the -3, and the third boundary, which is 0. Since 3 will give us a 0 value in the numerator and 0 divided by any value is 0 should be equal to 0. So meaning 3 will give us a true statement for this inequality. That's why we use the solidad here. The same also with -3. This will also give us a true statement for this inequality. So that's why we have a solidad here. This means that +3 and -3 are part of the solution set. And for 0 in the denominator will make the whole fraction undefined. So we have indicated here a hollow dot. So meaning these boundaries have divided the number line into 4 regions. This is the first region, this is the second region, this is the third region, and this is the fourth region. So we need to check values from each of these regions whether this will give us a true statement or a false statement. So we choose one value from this region here. For example, we will choose x equals -5. We can go back to the original equation or we can use this inequality here for our checking. For example, we will use this inequality. So we have here x squared. So -5, substitute -5 minus 9 over -5. So the square of -5 is 25, minus 9 is 16 over -5. So any negative number is less than 0, so meaning this is a false statement. So -5 gives a false statement for this region here, meaning all the values that can be found from this region are will give us a false statement. So we will not shade this region here. Let's proceed to the second region. For example, we will use negative 2 as the value. So we will substitute. We have negative 2 squared minus 9 over negative 2 greater than or equal to 0. So negative 2 squared is positive 4 minus 9 is negative 5 over negative 2. Now this time both numerator and denominator are negative, so that gives us positive 5 over 2, which is greater than 0. So therefore this is a true statement. Since negative 2 will give us a true statement, meaning all the values that can be found in this region will also give us a true statement. So meaning we will need to shade this region here. For the third region, we choose another value. For example, we choose 1. So substitute in the inequality, we have 1 squared minus 9. 1 squared is positive 1, minus 9 is negative 8, we copy over 1. So negative 8 over 1 is negative 8, is less than 0, so meaning this is a false statement. So all values that can be found in this region will give us a false statement. Let's proceed to the fourth region. For example, we choose positive 4. Substitute in the inequality. So 4 squared minus 9 is 7. Then copy 4 is greater than or equal to 0. So positive 7 over 4 is greater than 0. So this is a true statement. So meaning, if this is a true statement, all the rest of the values that can be found in this region until positive infinity will give us a true statement. So meaning, we will shade this region. So, the solution set for this inequality is being illustrated in this number line. So we have here the boundaries, we have the shaded region here, and the boundaries here. So to write the interval notation of this illustration here, this is now, we have the bracket, negative 3. This is a bracket because this is a solid dot, meaning negative 3 is part of the solution set. And up to 0. This is a parenthesis because 0 is not part of the solution set as being indicated in the hollow dot. Then we use the union because we have an interval which is not part of the solution set. Then another boundary which is positive 3, which is also part of the solution set, that's why we use a bracket. Then up to positive infinity, meaning all the values at the right side of this number line until positive infinity. When we use infinity, whether negative infinity or positive infinity, we will always use parentheses. So the solution set for this inequality is from negative 3 to 0, union 3 to positive infinity. So that's it. I hope again you have learned something from this video. But before I go, you need to try this exercise. So for the solution set, write your answer in interval notation. So number 1, we have 2 minus x over x minus 1 is less than 0. And number 2 is 2 over x is less than 3. So that's it. Thank you and God bless.